Hi everyone. In this video, we're going to talk about section 1.2, rates of change. So by the end of this video, you should be able to compare rates of change at 2 points using average rates of change near those 2 points. So first thing we're going to refresh our mind on is that in topic 1.1, we learned about the phrase rate of change. Remember from our Algebra 1 days that is similar to the word slope. So what that means for us is that if we have a positive rate of change, then we have a positive slope, which means our function is increasing. Remember, increasing means that our function is going up. Then we have a negative rate of change, which indicates that our function has a negative slope and our function would be decreasing, which means that our function is going down. So in this class, we'll define the rate of change of a function at a point as the rate at which the output values would change if the input values were to change at that point. So really, we're only going to use the words positive, negative, and zero. Okay? In order to find the actual rate at which it's changing there, that would be the instantaneous rate of change, which would require some calculus. So, again, the big part that we need to be able to do is for the rate of change at a given point is to determine if our rate of change is positive, negative, or zero. So we will also have to be able to compare the rates of change at two distinct points. So we need to know that going up is a positive slope and has a positive rate of change, and going down has a negative slope and a negative rate of change. Then we have a new one that would be at a maximum or a minimum where the point is neither positive or negative, or the rate of change is neither positive or negative. And at this point, the rate of change is zero. And so again, these happen at the top of the peak or at the bottom of the valley. So you're not moving up, you're not moving down. So we have this little roller coaster graph to kind of help us visualize what's happening. So first off, we have our positive rate of change. And so that would be right here at T1. This represents a positive rate of change. This graph or this part of the roller coaster is where it's going up. Then when we get to T2, notice it's at the top of the peak. And that right there represents a zero because it's constant, it's not going up, it's not going down. And so that would be our zero rate of change. Last but not least, we have our negative rate of change. That is when our graph is going down. And so that happens right here. That is not all the time or the only place it happens, that's just the one we're talking about. Okay? And so this just is showing you a roller coaster example of the different rates of change. So on our first example, the figure shows the graph of the function f in the xy plane with three labeled points. Order the rates of change of the three labeled points from least to greatest. So first thing we need to pay attention to is that it told us the name of our graph is f. Okay, we have 3 points, and so we want to talk about the rates of change at each point. Again, the only words we can use is positive, negative, and zero. So the rate of change at, we're going to start with point A. If we look at it, this is going up from left to right, which means this has a positive rate of change. If we look at point B, this is going down from left to right, which means this one has a negative rate of change. If we look at point C, that is at a valley, and at the valley or at the mountaintop, that is a 0 rate of change. So now we need to put these in order from least to greatest. Well, if we're putting them in order from least to greatest, the smallest one is going to be our negative value. Our next one would be our 0 slope. And our biggest rate of change is going to be our positive value. And so this would order our rates of change from least to greatest, from small to big. Okay, and example 2, I want you to take about a minute to read this question to see which answer you think is correct. So pause the video so you can try it on your own. So hopefully you pause the video. In example 2, the figure shows the graph of the function g in the xy plane with 4 labeled points. Of the following points, at which is the rate of change the least? So a couple of things. It told us the name of the graph is g, and it's asking us when g, the rate of change of g is the least. So what we're looking for is when g is the smallest. So we go through and we look. So next to each answer choice, let's go ahead and write if the rate of change is positive, negative, or 0. So if we look at point A looks like a positive rate of change. So I'm going to write that. If we look at point B also looks like a positive rate of change. We look at point C, we have a negative rate of change. And then lastly, point D is another negative rate of change. So based on this, if we're wanting the rate of change that is the least, we can eliminate A and B because they are both positive. So now we need to know which one out of C and D is smaller. The one that's going to be smaller is the one that is more steep than the others. When it's more steep, that means it's a bigger negative number, which means it's overall smaller. So the one that is more steep is going to be point D. It's a little bit more steep than the line at point C. So the correct answer is going to be D. That has the smallest rate of change. Okay. Now, another concept that we're going to cover throughout this class is the average rate of change over a function. You actually know what average rate of change is. You've seen it before. It's just maybe we just called it rate of change instead of average rate of change. Now, we do like to abbreviate average rate of change as AROC, so we don't have to continuously write this. So the average rate of change of a function over an interval is the constant rate of change that yields the same change in the output values as the function yielded on the interval. It's the ratio of the change of the output values to the change of the input values over the interval. That right there is the important part. It's the ratio of the change of the output values to the change of the input values over that interval. So what you have seen this as before, prior to this class, is if you have 2 points, let's say x1, y1, and x2, y2, what you're used to seeing is y2 minus y1 over x2 minus x1. Well, in this class, all we're going to do is we're going to change that to be f of b minus f of a all over b minus a. This is the same thing. It's just showing you that a f of a would be this right here, and then b f of b would be right there. So it's the same concept, it's just using different letters, okay? But this is the notation that we will be using throughout the class. When the function name changes, we change the letter of our function, okay? So let's take a look at our next question. The figure shows a graph of the function y equals h of x. Of the following, on which interval is the average rate of change of h the greatest? So again, it told us the function name, that this is h. We want to know when h is the rate of change or average rate of change of h is the greatest. So notice now they give us 2 points, they give us an interval. So what we're going to do is we're going to mark where 2 hits the graph and then where 3 hits the graph, and we're going to see. So when my x value is 2, it hits the graph right here. When my x value is 3, it hits the graph right here. If we were to connect those dots right there, notice that it creates a constant line, and the constant line has an average rate of change equal to 0. So now we're going to do 3 to 5. So 3 hits the graph right here, 5 hits the graph down here. We look at this part right there. That shows us that our average rate of change is negative because it's going down from left to right. So our average rate of change is negative. So now I go to the next one, 5, 7. So I put a point where x equals 5, a point where x equals 7. We connect the 2 dots. And we see that that right there has a positive slope. So our average rate of change is positive. And last but not least, 7 to 8. So here's our point at 7. Here is our point at 8. If we connect those 2 dots, we see that we have a negative rate of change. And so going back to our question, we want when the rate of change of h is the greatest. So we have 0, negative, positive, negative. The greatest is when our rate of change is going to be positive in this case. So C would be our correct answer. Okay. On example number 4, the graph of the function y equals f of x in the xy plane always has a negative rate of change. Which of the following definitions for the variables of x and y would best be modeled by the function f? So think about a negative rate of change. Okay, a negative rate of change means that as my x increases, my y will decrease. Or as x decreases, my y will increase. So essentially my x and y's are doing different things. So let's read. The age in years of a young child, and then y is the height in inches of the young child. Well, typically what happens as you get older, so if you started a baby to the time that you're, maybe 15, 16, what happens with your height? Well, as you get older, your height starts to increase. So therefore, those are doing the same thing. My x is increasing, my y is increasing. So that won't work. Okay? B, the total number of points scored in a basketball game to the time remaining in seconds. Well, if you think about it, at the beginning of a basketball game, I have, let's say, 60 minutes on there. And as the time goes down, the points are going up. Okay, at 50 minutes, I'm going to have more points than I did at 60 minutes, hopefully. At the end of the game, I'm going to have more points than what we did at the beginning of the game. So that's showing us that as our X values go up, our Y value, our time remaining, is going down. Okay, so that's a possibility. Let's read the other answer choices. The time in seconds since the ball was thrown straight up in the air and the height in the feet of the ball. So if you think about it, if you throw a ball up, okay, the height is going up. Well, as you do that, the time is also going up to match or to see how long it takes to go up. So my height is going up, the time is going up, so that one's not going to work either. D, the radius in meters of a circle and the area in square inches of a circle. Well, if my meters increase, my inches increase, or my square inches increase. So that's also not going to work. So the correct answer in this one is going to be B. Okay, we're going to skip example number 5, so we're not going to worry about that one. And we're going to go to example number 6. This one will require some calculator skills, but if you don't have a calculator, you can at least do the setup part right, and then once you get a calculator, you can type those in. Okay, so the table gives the life expectancy of U.S. females born in a given year over successive 50-year intervals, over which interval of the following intervals is the average rate of change of the life expectancy the greatest. So again, if you don't have a calculator, we can, just make sure we set it up and then we can go to the calculator steps later. So I'm going to let the birth year represent the variable t, and life expectancy, I'm going to name it L of t. And so what we're going to do is we're going to set up the average rate of change for each one of these answer choices using the formula that we talked about right here, which is essentially our slope formula. But instead of F, we're going to have L's. And then the A and the B is going to be the numbers from our interval. So if we look, our first interval is from 1800 to 1850. So this is going to be L of 1850 minus L of 1800 all over 1850 minus 1800. Okay, from here, we need to get what L of 1850 is and what L of 1800 is. So we go to our table, we find 1850 right here, and we find what is the life expectancy at that value, and that would be 46.10. Then we do the same thing, find 1800, and that would give us 41.24. And that's all going to be over 1850 minus 1800, which is 50. So from here, you could type that into the calculator and you can get a decimal. I want you to write all of the numbers. So it's 0 point something. Make sure you write all of the numbers that show up in our calculator screen. So what I want you to do is I want you to pause the video, and this is what I'm going to check tomorrow. And I want you to make sure that you have all 4 of these written. So I want you to continue doing the same process that we did for A, for B, C, and D. So pause the video and go ahead and write out each of these steps. And if you're able to get a calculator, go ahead and get all 4 decimals. So example 6, again, I want you to write this out for each one. So changing the 1850 and 1800 to the new intervals, and then using the table to help you set this up. And again, if you have access to a calculator, I want you to type those in. So this is what I'm checking tomorrow. So we need to make sure that this is done. Okay. So again, I'll check that tomorrow and we'll go over it. Now, I want to go to the next part where it says find the average rates of change for the following functions given the intervals, show all work. This is a no calculator part. Okay, so no calculator on this one. The only one you can use a calculator on is example 6. Okay, but this is the same process. So we have our function f of x, which is x squared. We have our interval. We want to find the average rate of change. Well, the average rate of change is equal to f. This is my a, this is my b. So f of b minus f of a all over b minus a. And so now we have to use our equation to help us evaluate. So to find f of 3, what we're going to do is we're going to plug in 3 into our x squared. Well, that would be 3 squared, which is 9. So I can change this first part, f of 3, to what it equals, which is 9, minus, I repeat that process with f of negative 3, which would be negative 3 squared, which also equals 9. On bottom, I have a double negative, 3 minus a negative 3. The double negative turns that into a positive, and so I end up getting 3 plus 3. Well, then 9 minus 9 is 0, 3 plus 3 is 6. 0 over 6 is 0. So this is what we get right here. Okay? And so 0 would be your average rate of change. Now we're going to repeat this process with a different function. If you want to pause the video to try it on your own, go ahead and do so. So on this one, again, we have our A, we have our B. So we have K of 4 minus K of 2 all over 4 minus 2. So I need to find K of 4. I need to find K of 2. So I'm going to start with K of 4. That would give me 6 times 4 over 4 minus 1. That would be 24 over 3, which simplifies to 8. So K of 4 is equal to 8. Then I can find K of 2. That would be 6 times 2 over 2 minus 1, which is 12 over 1, which equals 12. So I can go ahead and write that there. 4 minus 2 is 2. I can keep simplifying. 8 minus 12 is negative 4. Negative 4 over 2 is negative 2. So that would be my average rate of change. Okay, last question. Same concept, but now we have a graph instead of a equation. So m of x on the interval negative 6 to 11. So we're going to have m of 11 minus m of negative 6 over 11 minus negative 6. So m of 11, you find 11 and where it hits the graph, that's right there at 0. M of negative 6, where it hits the graph, is right here at 3. 11 minus a negative 6 is 11 plus 6. So I get 0 minus 3, which is negative 3. 11 plus 6, which is 17. So my average rate of change is negative 3 over 17. So if you have any questions over anything that we've done in these notes, please write them down here or next to the question you have or the example you have the question. That way you can ask me in class on Friday. Okay, so hopefully this wasn't too bad. Again, you have at one single point, you have three things. It can be positive, 0, or negative. If you're given an interval, like we were in example 3, then you're connecting the dots to see if you have a positive slope, a negative slope, sorry, a 0, a negative, positive, to see how you can order it. Or if you're given, an equation in some intervals, a table in some intervals, you can actually calculate it using our formula. So don't forget that example 6, you need to have this set up for each answer choice, so you should have 3 more. And if you have access to a calculator, I want you to also type those in and get those evaluated. So once you're done with these notes, then you're going to go ahead and complete your DOL for the day. Again, bring any questions on Friday. That way I can help you out.